All right, let's run through the homework.
Let's run through the homework. So the answers, if you recall, are at most of the answers are at. Excuse me. Hopefully you're still talking. So most of the answers are at towards the back of the packet as far as this section goes. Yes.
Yes.
Okay. So, what kind of questions might we have come across?
Number 8.
Number 8.
Number 14.
Okay, you pull yours out so I can take it.
Oh, where are you asking us to?
Yeah, so number 8.
14.
8 and 14. Hang on.
17.
Hang on. Stop. Please. Number 8, we have x is less than or equal to 3. Okay? Number 8 says graph the inequality, then write it in interval notation. Okay? Number line, put a 0, put a 3. Still with me?
Yeah, close that.
Okay, closed dot y. Yeah, that's going to give us the closed dot here. And then I want to shade values that are less than 3, so I'm going to shade to the left. Is that right?
Yeah.
And then we want to do this in interval notation. So starting from the left, where are we coming from? Negative infinity. And where am I going to? 3. Am I including the 3?
Yes.
Square bracket, solid dot, square, solid, go together. Yo.
I got 3 and negative infinity.
That's incorrect.
Why?
Because where are you coming from? You're coming from negative infinity. Okay.
So it's always left to right.
Or right. Wait, can you count the positive side and then if you write
Well, this
No, like
indicates that it starts at the 3. It includes the 3.
Okay.
Don't have a square bracket over here.
Okay.
Other questions we had?
Number
17? Alright, 7 over 3x
14.
plus 3 over 2 equals 23 over 6. So this is just an equality. It's equal, right? Let's get rid of the denominators first. What should I multiply all 3 by? 6 over 1. Good. Okay, so this goes in there. That's twice. So this becomes a 14x. Agree?
Yeah.
This goes in here 3 times. That becomes a 9. Agree?
Yeah.
That goes in itself. So I just keep the 23. And then from there we would solve it. What's
14.
so x equals
1.
Oh, hey, how are these being held together? What math operation?
Multiplication.
Multiplication. So the number next to a letter is multiplication. So undo it by dividing. So divide yourself by 14. So that's a 1.
Okay.
All right, Ram, you had one. I thought.
It was number 14.
Number 14. Okay, the number of suitcases lost by an airline is at least 93 per day. Oh man, that's no fun.
Dang it.
Okay, so they lose at least 93. Could they lose more?
Yes.
Yeah, it says at least 93. So that means that on any given day, it's at least 93 that are lost. It could be a lot more. So they're losing at least 93, and it goes up to an infinite amount. I mean, obviously, you don't have an infinite amount of suitcases, but it could go from 93 to all of them, which that would be a really bad day of being in the airline industry. Okay. Did they want those graphed? I don't know if they were graphed or not.
Discrete or continuous? No, they didn't.
Um.
Yeah. You can't have.
So yeah, I think you're right. I don't know. I don't know how many suitcases there would be.
Yeah, but you can't have half a suitcase.
Right.
Oh wait, yeah. But it's infinity, so.
Those small ones.
So what if we did this? So they lose from 93 to all of them.
Well, will it not be infinite? It could be an
What? So what are they asking? Oh, can I see?
discrete.
Decide if the values are continuous or discrete. So, so I think they would be Can I have 93.1 that I lose, or 93.2? No. Oh, you lose the handles. Like you lost 0.1 of that suitcase. So I guess you could argue it both ways, right?
Yes, the clothes are in the suitcase. Yeah, but they're not part of the
Suitcase.
suitcase.
All right. So I guess we have a kind of a question on how, could we go 93.2 suitcases lost? I guess yes, a portion of a suitcase could be lost or get ripped off, and whatever. What other questions we have? Yeah.
Number 16.
16. Number 16, is this one of those discrete and continuous ones again?
That is.
That's on the back. All right. This is an equal. Is that equal?
What's an APE and an MPE?
Addition property of equality or multiplication of equality. Oh, okay.
Like, what are those?
Is this what the problem is? Is that what it is?
Yes.
Okay. So being that these are being multiplied together, and I divide each side by 6, and then I could reduce that to 11 over 2.
No, 33 over 6.
33 over 6 is not reduced. 3 goes into both.
Exactly.
33
So you need to reduce it though. 3 goes into 33 11 times. 3 goes into 6 twice. So it can be reduced. All right. So then they wanted us to know. Did we use addition or a multiplication property here? And this is the multiplication property of equality. Because these were being multiplied together, in order to undo multiplication, you have to use division. Anything else?
Oh,
Yo. Go ahead.
Number 19, I think. Yeah.
19.
No solution.
19. Looks like a no solution possibly. Let's take a look.
19. No, yeah. That leaves me
Okay. Am I allowed to just drop these parentheses as they sit?
Yes.
Okay? Everyone feel okay with that?
Yes.
Can I drop these parentheses as they are?
Yes.
I'm not distributing anything over them. They're just having grouped for whatever reason. So then if I add these together, I get 2y plus 3 equals 2y plus 5. If I subtract 2y from either side, we're going to get something weird like 3 equals 5. Or you could have gotten 0 equals 2, which that's weird. That shouldn't happen. So that means there's not a solution to this problem. Are there any others we want to take a look at?
No, sir.
Let's go with 17.
Did it?
Just
All right, hand them in, please. Make sure your name's on the top. If you're handing in anything old, also. 15, please. 15. All right, solving linear equalities, part 2. Solving linear equalities, part 2. So yesterday, we just talked about less than, greater than, less than equal to, greater than equal to. So sometimes they had a solid dot, sometimes they had an open dot, depending upon if you had the equal sign involved. Sometimes you use a square bracket, sometimes you use a parenthesis. So there was all these different types of things. So we're still going to continue to use those, but we have to realize that these problems, well, we know how to do this. What do I have to do to this first problem right here? Whoa. Not that. What do I do? Distribute what? Negative 2 here and here, right? So I'm going to get 5 minus 2x minus 8 is equal to 7. Combined like terms, so it looks like 5 and negative 8 are the same. And then add 3, right?
Right.
And then divide by, because negative 2 and x are being held together, the multiplication, divide each side by, so what? Negative 5? There we go. That worked out nicely. And then we got to one like this, and we know we have to do what to it to get rid of fractions? Multiply each of the 4 terms by 6 over 1, or just 6, thank you. So this goes in there, that becomes 3x. This goes in there, that becomes plus 2. That goes in there, that becomes 1 plus 6x. Is that all right? And from there, I'm going to start subtracting. So subtract 3x from either side. Because 6 times 1 over 6, the 6's cancel. So I get 2 over here equals 1 plus 3x. Subtract the 1. And then how are 3 and x being held together? Multiplication. What does multiplication? Division. So x equals 1/3. All right?
Wait, hold on.
Yep.
I subtracted 1 x. Oh, I got the x wrong.
Gotcha. Cool. May I move on? We good? All right. So we're going to solve the following, and then we're going to write it in interval notation. So remember, interval notation is square bracket versus parenthesis. Okay. So problem number 1. Let's just take a look at problem number 1 for right now. And just by looking at it, will it have square bracket or parentheses? Parentheses. So does everyone feel okay knowing we have parentheses? I don't know what it's going to work out yet, but why does that parentheses not a square bracket? Yes?
No underline.
No underline. So then, now, so this is my first thing. I know that my answer is going to have that as part of it. So let's figure this out. How, if this was equals 10, what would I have to do to get x by?
Add 5.
Yeah, so I'm going to do the same thing. So I'm going to add 5 to both sides. So let's bring this over here. So I'm going to get x is greater than 15. So now I want numbers that are larger than 15. Do I include the 15?
No.
No. So I'm going to go from 15 to where?
Infinity.
To positive infinity, right? So that includes 15, or 15 point whatever, 16, 17, 18, 19, all the way up to infinity. Okay? So remember, this is the interval notation. They're both parentheses because it's not underlined. It's always a parenthesis next to the infinity or the negative infinity because we can't get there. Okay? Problem number 2. Let's take a look at problem number 2. Just by looking at this, can you tell me if it's square bracket or rounded brackets? Rounded, so parentheses, right? Everyone feel comfortable with that?
Yes.
So our answer will have to be that way. 2 and x are being held together by what? Multiplication. So I'm going to divide each side by 2 because these were held together by multiplication. So that reduces. So then I get
X equals 2.
x is less than 2. Okay? X is less than 2. Okay, so I want values that are smaller than 2. So 1 and 0, -1, and all the decimals in between, right? So where are we heading to? So where would this be coming from? Negative infinity, and I'm going up to what? 2. There you go. That's all it is. Okay? If you write 2 comma negative infinity, that's incorrect. So this is saying, hey, where it's going to negative infinity. Okay, so where would we be starting from? Negative infinity going all the way up to 2. Why is it a rounded bracket? Because it's not equal to it. I don't have the line under it.
Wait, so if there's an infinity, but it has to be a square or a round bracket.
Yeah, infinity will be always rounded. The bracket next to infinity is always rounded. All right. This one, we need to know that it should have a square bracket someplace in there because of the line underneath. Okay, both sides don't have to have it, right? Especially if one side has the infinity on it. So if I solve this, first thing I would do is I'd subtract 8. That gives me 2x is less than or equal to -4. And I'm going to divide by what? 2. If I divide by 2, so I'm dividing by a positive number, so I'm going to get x is less than or equal to
2.
-2. Okay, so where am I going? Negative infinity. So where am I coming from? Negative infinity, and I'm going up to what? Am I including -2? So this is a square bracket.
Yay.
Cool? Making sense? Anybody stuck? Okay, may I move on? Here we go. All right, now for smarter ones, graph the answer and write it in interval notation. Okay, so first thing I want to do when we're dealing with this, it's always easier if the letter is on the other side. Is that okay for me to say that? So take a look at what we had before over here. we had the letter on the left side, okay? So let's make the letter on the left side first. So let's do this. Let's do this. What did I just do to the whole problem? I flipped it. Did the sign flip over as well?
Yes.
Yes. So can you make that work in your head that that is the same thing? So from here, what am I going to do to get x by itself? Add 3. So I get x is greater than or equal to 9. Being I have this, that means I could have a square bracket in there, right?
Yeah.
So do I want values bigger than 9 or smaller than 9? Bigger. Am I including 9?
Yes.
Yes. So square bracket. Where am I going then? To infinity. Rounded bracket because I can't get all the way there. Problem number 5. I want to have the x on the other side. So what should we do? I'm going to flip the entire problem over, including the sign. So that's going this way. So now I'm going to go this way. Yeah. Say that one more time. Okay, being I'm flipping over the entire problem though. You're correct to say what you're saying, but being I'm just rearranging the whole problem, so the x on the other side, I have to move everything over so the sign itself flips over. So I'm not multiplying or dividing by a negative in this case. I'm just manipulating the problem so that my x is on the left side.
Same example.
Okay? So subtract 18. Is this going to be parentheses or a rounded bracket? Rounded bracket, okay, because it's not equal to. So subtract 18. So I get 2x is less than negative 6. So divide by 2 because 2 and x are being held together by multiplication. So x is less than negative 3. Did I divide by a negative at all? No. I divided by positive. It happened to be the other number was negative. So I want values bigger or smaller than negative 3. Smaller. So where am I going to? So that's where I'm coming from, right? That's where that's heading to. And I'm going to go up to what? Negative 3. What's my bracket? Rounded. Done. How do y'all feel? Seem okay? Yesterday it was a little baffling, but I think some people, it's sunk in. I think it's sunk in a little bit. All right, now let's think about this one. What would work for x? So I want values that are negative. All right, so how are these being held together? And I'd say it's got to be some sort of bracket rounded. So if I divide each side by negative, I want values are. Oh wait. I'm gonna. Okay, negative 2. The sign needs to flip. If I divide by a negative, I have to flip the sign over. If I divide or multiply by a negative to get it over on the other side, I have to flip the sign over. So let's make this work. If I wanted values, if I wanted our original to work, if I were to plug, say, positive 3 in, I'd get negative 9 times positive 3, which is negative 27. Is that true in this case?
No.
27 is less than, or negative 27 is less than 18, right?
Wait.
So think about this.
27?
So think about it. Well, if I plugged a positive 3 in right there, I'd get negative 27. Negative 27 is less than 18, correct?
Yes.
So that means I want values that are larger than negative 2 to plug in here. Okay? Like if I plug negative 1 in here, I get negative 9 times negative 1, which is positive 9, is 9 less than 18. If I plug 2 in, negative 9 times 2 is negative 18. Is negative 18 less than negative 18 less than 18? Yeah. Okay? So I needed to flip the sign. This needed to take place because I multiplied or divided by a negative. So I'm starting with negative 2, not including it, and I'm going to where? Positive infinity. So if you multiply or divide by a negative number, you need to switch the direction of the inequality sign. Does that say anything about adding or subtracting a negative?
No.
Does that say anything about if you divide a number that happens to be a positive number, but the answer turns out negative? Does any of that come into play?
No.
So the actual physical thing that's taking place is I am multiplying or dividing by a number that happens to be negative. If the original number was negative and I'm having to multiply or divide by a positive, the sign doesn't flip. I have to flip it when I multiply or divide, when the actual multiplication or division that's taking place is being done by a negative number. Huh. You doing okay?
Yeah.
Life good? Alright. Solve the inequalities, graph the answer, write it in interval notation. Okay. So problem number 6. Let's see. Who have we not picked on in a long time? Steve B, I haven't heard from you in a bit. What do you got? I have negative 4 times y is greater than or equal to negative, or it says 16. So what do you think I should do to both sides? Divide both sides by a negative 4. And being I'm dividing both sides by a negative 4, what do you think the sign's going to do? It's going to flip-flop. And then I'm going to get negative 4. Okay? Do we want numbers bigger than negative 4 or smaller than negative 4? Smaller. So where are we coming from?
Negative 4. Or negative infinity.
Negative infinity. Where am I going to?
Negative 4.
Am I including negative 4?
Yes.
Why is that?
Underline.
It's underlined. It's included. Okay? What does it appear I need to do on number 7 first? Distribute. Is the sign going to flip at this second? No, I'm just distributing a negative over the parentheses. It's when I have to move it to the other side of the parentheses I need to worry about it. Does that seem okay so far? Combine like terms, so I get negative 2x plus 7 is greater than 11. And then what? What should I do? How do I get x by... Subtract 7. Good, I like it. Subtract 7 from both sides. So let's bring this here. That's going to give me negative 2x is greater than 11 minus 7 is?
4.
4. Now what am I going to do?
Divide by negative 2.
Divide by negative 2. Being I'm divided by negative 2, anything... Yeah, x is smaller. The sign has to flip. And that's a what? Negative 2. Okay? So I want values smaller than negative 2. So where am I coming from?
Negative infinity.
Negative infinity. Where am I getting to? Negative 2. Am I including it?
No.
No. So it's a parenthesis.
Wait, so does that mean that if we plug anything smaller than negative 2, it'll
Make
be
the original
smaller?
true. It'll make the original true. So if I were to take, let's say, negative 3 and plug it into this, it's still going to be true. Okay? All right, x over 7 minus 2x over 3 minus 1 over 7.
21.
So 21 looks like a really good thing. I have 4 terms up there. I'm going to multiply this by 21 over 1, and this by 21 over 1, and this by 21 over 1, and this by 21 over 1. So that's going to give me what? 3x minus, that's 14x, good. That's minus 3 is less than or equal to 30. Did I do that right? Okay. Let's see if I can move this, squeeze this up here. So I'm going to combine like terms. So I get negative 11x minus 3 is less than or equal to 30. I'm going to add 3 to both sides. And then I divide each side by what? Negative 11. If I divide by a negative, what do you know about the inequality sign? Flips over. That becomes negative 3. So I want values bigger than negative 3 or smaller than negative 3? Bigger. So I'm starting square bracket with negative 3. Why is it a square bracket?
Underline.
It's underlined, and I'm going up to what?
Infinity.
Infinity. There we go. Is that all? We're done? Kidding? How do y'all feel?
Good. Good, sir.
Seem good? All right, so your assignment for the next time we have class is going to be the next page in our notes. Let's see, what is that?
Page 47.
It is there's a 2.2.
Page 47.
What is it, 47?
47.
Page 47, 48. So 2.2, okay. So page 47, page 48. So you have time. It looks like we have about 15 minutes right now before we get out of here. You know, I know a lot of you are probably going to the football game, so why don't you get a good start on this? And that leaves you less to do for tomorrow. Steve, can you flip those lights on for me, please? Thanks, buddy.